From the previous video, we said that a parabola has an eccentricity of 1. So we define a parabola as the locus of points. The locus of points which are equidistant from a fixed point and a fixed line. The fixed point is the focus, while the fixed line is the directrix. So that would look like this if we have a fixed point which say we call F and a fixed line which we call D. Intuitively, if the parabola is the focus of points which are equidistant from the fixed point and the fixed line, we would place it exactly between the point and the line, say here. Now I need to emphasize the distances or the distance between 2 points. The distance between 2 points is a straight line, while the distance between a line and a point is actually the perpendicular distance. No? So just for us to be very clear about it. So this means that this distance is equal to this distance. So that if the point P will move, it should be in a manner that it maintains its distance from, it maintains that equal distance from P and D. Say this should be equal to this, like that. So the parabola is formed like this, in both directions. Now, so what is the equation of this geometric figure? What is its equation? As we said previously, we can find the equation if we are to sketch the graph on the xy plane. So for example, this is the xy plane, like this. This is x, this is y. Now, we can actually place the parabola, that green figure there, we can actually place it anywhere on the xy plane. But to simplify, let this extreme point coincide with the origin. No? So if that extreme point will coincide with the origin, say here, then the focus would be somewhere here. Let's call that point F, and the fixed line would be somewhere here, which is the directrix. So let's designate it with a D. So the parabola would be this, like that. So this point, which is doesn't look very well placed, but this is supposed to be equal to this. So from the equation that says the distance between P and F is equal to the distance between P and the line D. If, well, by convention, the distance between the vertex and F is A. So the distance between the vertex and F is A. So F now would have coordinates what? X is A, Y is 0. So F A. While this, the equation of this line would be what? The equation here would be X equals negative A. Negative A, right? So with those information, using the distance formula, the distance between 2 points, the coordinates are of course X and Y. So we'll have what? The square root of x2 minus x1, so that would be x minus A squared plus y minus 0 squared is equal to what? Is equal to x minus A is x plus A. So simplifying this equation now, we'll get what? We'll get the square root of x squared minus 2ax plus a squared plus y squared equals x plus a. Getting rid of the square root, we'll get what? X squared minus 2ax plus a squared plus y squared equals x squared plus 2ax plus a squared. Combining similar terms, we get x squared will disappear, a squared will also disappear. What is left is what? Y squared equals 4ax, which is the equation of a parabola that opens to the right. Similarly, if the parabola opens to the left, then the equation would now be y squared equals negative 4ax. This opens to the left. And if we will change axis, when the parabola opens upward, then we'll have the equation x squared equals 4ay. This opens upward. And x squared equals negative 4ay is a parabola that opens downward. So we were now able to derive the equation of a parabola. Going back to our figure, so a parabola has a focus, has a directrix. The line passing through the vertex and the focus is called the axis of symmetry. In this case, it coincides with the x-axis. And if we are to look at that line segment that passes through the focus and is parallel to the directrix, meaning this. No? This chord is called the latus rectum. Latus rectum. As you can see, no, the length of the latus rectum is actually 4A, which is twice this 2A, which is twice the distance from the vertex to the focus. A is the distance from vertex to focus.